All right, this is going to finish up section 4.4. We're taking a look at converting values, and we're on number 7. So in this problem, we're trying to take a number that's in base 5, and we're trying to turn it into base 7. And when we do this, we're always going to go through our base 10. So there will be 2 steps to this conversion. Now, what you learned on the previous slides is that when we turn something from, say, base 5 into base 10, we multiply. And anytime we turn something from base 10 into some other base, we divide. So we have our number 43, and this is base 5, so it's the ones place and the fives place. So we start out with taking 4 times 5 plus 3 times 1. And once we get this, which is 23, we have our base 10 number. So now we're in 23, and if you wish to be very clear, sort of as you're working, you're in base 10, so you can write a subscript of 10. If you don't write it, it's understood there. And then I want to turn it into base 7. Now in base 7, we have the ones place, and then we'd have the sevens place, and then if it's 7 squared, whoops, that's actually the number 49. So that's too big, right? So we're only going to be dividing by 7 as our biggest value. So 7 into 23, 7 goes into 23 3 times. 3 times 7 is 21, and we subtract. So we have 2 left over. So 1 goes into 2 2 times. 2 times 1 is 2 for a remainder of 0. And again, just like the other ones, our answer's on the side. This is 3 2, and we are in base 7. Okay, we're going to do another one. There are some other ways that you can work when they're specifically in powers of 2. Notice base 2 here is turning into base 8, which is another power of 2. But because we've already established that we can do this for any bases with 5 to 10 to 7, I'm going to do it exactly the same way. So I'm going to turn something from base 2 into base 10, and then we'll go from base 10 into base 8. And remember, a number into base 10 is to multiply, and a number from 10 into something else, we do division. So these are powers of 2. So, oh my goodness, there's a very long one. So I've got 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1. And let's see if we can figure out what the powers are doing here. Okay, so this is the ones place, 2. This is 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7, 2 to the 8, 2 to the 9, and 2 to the 10. So I think it's going all the way out to 2 to the 10. I'm multiplying, so actually anything that's a 0 I don't need to do because it's just going to give me 0. And all of these ones that are ones, because I'm multiplying by 1, just give me the power. So I really just have 2 to the 10 plus 2 to the 9 plus 2 to the 7 plus 2 to the 5 plus 2 to the 4, 2 to the 3, 2 to the 2, and then at the very end I have 2 to the 0, which is 1. So I've got some powers of 2 here. 2 to the 10 is 1024. 2 to the 9 is 512. 2 to the 7 is 128. 2 to the 5 is 32. 2 to the 4 is 16. 2 cubed is 8. 2 squared is 4. And then we have our 1. And if we add all of these together, we will end up with 1,725. And that's my base 10 number that I'm looking for. All that work to get to base 10. Okay, but I'm heading for base 8, right? So I need powers of 8 that I consider. Well, I've got the ones place. I have 8. 8 squared is 64. 8 cubed is 512. And I think 512 means I'm probably big enough, or nearly, right? I mean, if I do it times 2 again, I get 1024. I'm getting awfully close to the 17 that I have. And if I multiply, oh, I'm sorry, I multiplied by 2, not by 8. Let's start that again. 512 times my 8, that's 4096. That's too big. So I was right the first time when I was thinking I was big enough. So this is too big. This one was 8 to the 4th. It's too big. So these are the 4 values that I'll be dividing by. So I have 17, 25, and I'm going to divide by 512. So it goes in 3 times. 3 times 512 is 1536. If I subtract, I get 189. Then I'm going to divide by 64. It goes in twice. So 2 times 64 is 128. And if I subtract, I get 61. After 64, I divide by 8. So this one goes in 7 times, which gives me 56. And if I subtract, I will get a 5. And if I divide 5 by 1, I get 5, of course. Multiply, subtract, I get 0. So the answer is over here. It's 3275. So 3275 base 8. All right, our last example is actually writing them in order from least to greatest. In order to figure out if something's smaller than another one, we need something in common, in particular the bases. If I can turn all of these into base 10 numbers, I'll be able to compare them. And because they're all given in other bases, I can do that with multiplication. So remember, we turn other bases into base 10 by multiplying. So in base 7, I will have 4 times 7 plus 3 times 1. In base 4, I'll have 1 times 4 squared, because I have the 4's, 3 numbers on this one. 3 times 4 to the first, plus 2 times 1. And with A12, A is again the number 10. I have a 2-digit number, so at base 12, it's times 12. And then plus the 2 that's being multiplied by 1. So calculate each of these individually. The first one is the number 31. The second one is actually the number 30. And then the last one is the number 112. So this one says least to greatest. So the least is this one. The second one would be here, and the third one would be here. But I'm not going to really write down 30 is less than 31 is less than 112 or put them in that order. I need to represent them with their original form. So the number 30 that's in the middle was the number 132 base 4. The number 31 at the top is the number 43 base 7. And then the number at the bottom, of course, is the number A2. Oh, I'm sorry, it was base 11. I totally wrote that down wrong. I did the multiplication right, but I just wrote it down wrong. Base 11 should have been, this one should have been 11. Sorry about that. Base 11, so A2 base 11. It is really 112 and base 11. All right, so those would be the numbers in order from least to greatest.